Every single time you go online, you're playing by a set of invisible rules, this whole digital traffic code that just makes everything work. Today, we're going to pull back the curtain on one of the most crucial parts of that code, the network part. So let's dive in. Seriously, think about that for a second. You send a request to a massive server, like one of Google's, and that server is doing a million things at once. It's serving up web pages, handling file transfers, dealing with emails, you name it. So how does your little request for a web page find its way to the right department without just getting lost in the shuffle? Well, the answer is in this totally brilliant system that honestly works a lot like a digital postal service. And to get our heads around it, all we need is a simple analogy. Just picture every server on the internet as a giant office building in a huge, sprawling digital city. Okay, so first things first, before you can find the right office inside that building, you obviously have to find the right building itself. And in our digital city, that's where the IP address comes into play. Every single device that's connected to the internet, your phone, your laptop, that server, it has its own unique IP address. It's literally the street address, a string of numbers that tells your data exactly which building in this entire digital world it needs to find. So, great. Your request has arrived at the correct street address. It's standing there in the lobby of the right server building. But this building has thousands of doors, and each one leads to a completely different service. So which door does it knock on? This is where the real magic happens. This is the secret door number that makes sure your request for a web page doesn't accidentally end up in, say, the file transfer department. This, my friends, is the network port. Now, a port isn't a physical thing you can, touch. It's a logical connection point, basically a number that acts like an office or an apartment number. It tells the server not just that you've arrived, but exactly which service inside you're here to see. So let's just put it all together real quick. The IP address, that gets your data to the right building, the server. Then the port number takes over and guides it to the right door, the specific service you actually need. It's that combo, the address and the port, that makes the whole thing work. All right, let's see this in action, because that's where it really clicks. We're going to send two totally different requests to the exact same server and just watch how the port number works its magic. Okay, first up you type google.com. Your browser immediately translates that name into Google's IP address. But, and here's the key part, it also quietly tacks on a port number. For a secure website, which is most of them these days, it adds port 443 for HTTPS. When the server sees that request arrive with 443 on it, it knows instantly, they want the secure web page, and sends you right to its web service. And that just illustrates the handoff perfectly, right? The IP address is the navigator. It gets you to the destination. But as soon as you're there, the port number takes over. It's like the receptionist directing traffic once you're inside the building. Okay, now here's where it gets really interesting. Let's imagine that Google also runs a file transfer service on that exact same server. You don't want to see a web page, you want to download a file. How does that work? So your request is sent to the very same IP address. Nothing's different there. But this time, your file transfer program attaches port 21. When the server gets the request, it just looks at the port number and goes, oh, port 21. This one goes to the file department. It's the same building, just a different door, leading to a completely different service. And that is the power of the port. So we know 443 is for secure web, and 21 is for files, but who makes these rules? Is it just a total free-for-all? Nope, not at all. There is a very organized system behind all of this. Get this. In total, there are 65,536 of these port numbers available, running from 0 all the way to 65,535. But they're not just a random jumble. They're actually sorted into 3 very distinct categories, and each one has its own job. So if you look at this table, you can see the breakdown. First, you've got the range from 0 to 1,023. These are the well-known ports. Think of them as the VIPs, reserved for super common universal services like web traffic and email. Then you have the registered ports. Companies can basically reserve these for their own specific software. And finally, there are the dynamic ports. These are the temporary ones. When your computer starts a conversation, it just grabs one of these to manage its side of the connection. So it all seems pretty straightforward, doesn't it? The big servers are the buildings with all their well-known ports, and our computers are just the clients, the visitors, using temporary ports to knock on their doors. But what if I told you it's not actually that simple?
That's right, the roles can completely flip. Your own computer isn't always just a visitor, it can be one of the buildings. It can absolutely be a server.
Just think about it. If you've ever hosted a multiplayer game or used certain file sharing apps, your PC actually claims a port and starts listening for other people to connect to it. It's no longer just making requests, it's acting like a server, ready to direct traffic just like Google does. And that really gets to the heart of the matter. The labels server and client are just roles, they're not fixed identities. The real question is always this: which device is listening for a connection and which one is initiating it? Any device that's listening on a port is, at that moment, acting as a server. The humble network port. It's just a perfect example of this invisible logic that makes our entire digital world possible. It's a simple, super elegant solution to a really complex problem. And it kind of makes you wonder, doesn't it? What other secret rules and hidden handshakes are happening behind the scenes every single time you click a button?